right? And then next problem is again a simple problem on ladder, right? So here what is that is asked here is you are given a lean angle. This angle is dictated in the problem because the dimension 12 here and 5 here. So this angle theta would be tan inverse of 5 by 12. So what is that? You get tan inverse of 5 by 12 is 22.62 degrees. 22.62 degrees. So if this angle for this uniform ladder it is said, so let me draw a free body diagram of this ladder, and at the mid span I'll have the weight of the ladder, say not given, so let us consider that as W, that's vertically acting down, and I have both the contact surface, the point A and B, same value of mu. And what is that smallest value of mu required to maintain this angle so that this won't slip down, right? Of course, if person climbs up, then you have to consider weight of the person also. But the question is not that. I have this ladder, I want to just lean on this wall with this dimension. This dimension is imposed because the ladder length is of 13 meters. So that would satisfy. If this is of 13 meters length, Pythagoras theorem under root of 12 squared plus 5 squared would give you 13 meter here, right? 13 meter. So that satisfies. That is what this configuration is dictated. What is the minimum value of mu, smallest value of mu as, so that this is maintained when the ladder is just lean on this vertical wall for this angle. That's the question. So whenever you have such problem of ladder, you should consider, since it is smallest value, I should consider both the point. If this motion impend, then that would be the condition for finding this. So I know that at point A, I will have normal NA, and my friction force would be maximum static friction force, and that would act in this direction. And I do not know its magnitude, but it is given by mu times NA. So I consider mu s times NA, maximum value of this. Similarly, at point B, I would have this normal NB. And since this ladder is sliding down expected, the tendency is down. So this friction force will be upward force. That would be mu s times NB. So this is the free body diagram, that's all. If you have drawn this free body diagram, you are getting a way to solve this problem. So you have three conditions of equilibrium. The two equations, of course, are this FB is mu s NB and FA is mu s NA. That's from law of friction. What would be the maximum value possible here for this friction force to maintain equilibrium? And you have three conditions of equilibrium. So let us use those equations. So one is sigma Fx equals 0. So when I apply that, here how many horizontal forces are there? One is mu s times NA, another one is NB. So I would have my equation minus NB, because that is to the left, plus mu s times NA equals 0. So I get my NB is given by mu s times NA. So this is equation 1. And then let me find out the relationship between, or find out NA. So for that, let me take moment about point B equating to 0. You can also take moment about point A and have another way working out, nothing wrong in it. But I take now moment at this point, so that I will have now NA related with the W. So if I do so, what is that I will get when I take moment at point B? These two forces, NB and mu s times NB, won't come in the equation. The rest will come. Since it is of uniform ladder, this is W. So this distance from this wall is midpoint here by similar triangle principle. We can find that distance. So this is 5, this is 2.5 meter from here. So when I take moment, W would create at point B counterclockwise moment by multiplying W by its momentum 2.5 meters. 2.5 meters. And then mu s times NA would create again counterclockwise moment. So plus mu s times NA is the force, multiplied by the momentum 12. And this would create, NA would create about point B clockwise moment, so minus NA, sorry, minus NA into 5. That's all equal to 0. So I would get from here NA in terms of W, all right? So what is that I have? Let me take NA out. So that's going to be 12 mu s minus 5 plus 2.5 W equals 0. So I can write NA as 2.5 W divided by, I take it on that side minus, that minus sign I take it in this. So it is going to be 5 minus 12 mu s. So this is equation 2. So I have NA in terms of W and NB in terms of NA. Now I have my third equation. What is my third equation? Sigma Fy equals 0. Sigma Fy equals 0. So when I apply that, it is going to be NA minus W plus mu s times NB equals 0. So I would use this equation 1 where NB is mu s times NA, substituting here, correct? So from 1, I can rewrite this equation 3 as this. So NA minus W, NB is what is mu s times NA, so plus mu s square NA equals 0. So this would become now NA, if I take out, I would have inside 1 minus, sorry, 1 plus mu square, 1 plus mu s square minus W equals 0. So that solves for NA. So NA equals W by 1 plus mu s square, right? W by 1 plus mu s square. So this is equation 3. So now equation 2 and equation 3, you look at, they are equal. So equation 2 equals equation 3. That gives you 2.5 times W by 5 minus 12 mu s to be equal to W by 1 plus mu s square. So this W on both sides goes off. I get a quadratic equation in mu s by cross multiplying. So that's going to be 2.5 plus 2.5 mu s square equals 5 minus 12 mu s. So this equation again can be rewritten as 2.5 mu s square, and this 12 mu s on this side, if I take it, is 12 mu s, and here I have 2.5, this 5 comes here, it is minus 5, so minus 2.5, that's equal to 0. So look at, this is the quadratic equation mu s. It's very simple to solve. Solving this, you can solve this using calculator. You get mu s value, two values, one is 0.2, another one is minus 5. Minus 5, yeah. So this is not realistic. So you take this value, 0.2. So the mu s value is 0.2. So that's the smallest value of mu s. This can be stable. What do you mean by that? If you have any value of mu s greater than 0.2, if I have 0.3, this is of course stable. If I have less than 0.2, then this would not stay. That is the meaning, right? So this is that another question from friction. We have solved the problems on ladder. I hope you could have solved this problem also well in your examination. Then you had your next module question. This is very straightforward, simple. Where you have to find out area moment of inertia. Determine the second moments of inertia of the shaded area in figure 3 with respect to centroidal axis, respectively parallel and perpendicular to side AB. So